All right. So what we're doing today is we're finishing up chapter 3.6, which is actually the finish of chapter 3. Now what we started on Friday and what we're continuing on with today is the quadratic formula, solving these equations using the quadratic formula. Now the quadratic formula is given to us by the equation x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is our formula. Now to use it, the first thing we have to do is get the quadratic equation equal to 0. Got to get it equal to 0. Now with this equation here, yes sir? You're just poking your head in? Okay. Yep. Yep. You too. So, when we look at this here, we got to get it equal to 0. So the first thing we can do is add 7x to both sides. It really doesn't matter how we move it from one side to the other, which side we make be 0. Because here we can add 7x, which is nice because negative 7x plus 7x is 0. 2x squared, 7x, and 4 are not like terms, telling us that we have 2x squared plus 7x plus 4. The other option is that we could subtract 2x squared from both sides and then subtract 4 from both sides and get everything onto the right-hand side. I would not do that. It's not that it's wrong. It's not that we can't do that. But I would rather move one thing over than move 2 and still get the same answer. Now the general form for a quadratic equation is ax squared plus bx plus c. And we can match these up to figure out what the values of a, b, and c are. A in our case would be 2, b would be 7, and c is 4. Now we do take the sign in front of each of these numbers. So 2 is positive, 7 is positive, and 4 is positive. Now we're going to take those values of a, b, c and plug it into the equation. Plug it into the formula. So we have negative b, so that would be negative 7. Plus or minus the square root of, so b squared would be 7 squared. Minus 4 times a, well our value of a is 2, times c, which is 4. All over 2a, so 2 times 2. So all we did was take the values of a, b, and c. So we replaced a. Since a is 2, we replaced the 2 spots where a is at with 2. B is 7, and c as 4. Questions on how we plug this in? Now we just need to simplify. So our negative 7 is, well, negative 7. The denominator 2 times 2 is 4. Now most likely this is not going to reduce. There's not going to be a greatest common factor on top and bottom because 7 and 4 do not share a common factor. Square root 7 squared minus 4 times 2 times 4. So I just grab the calculator and say 7 squared minus 4 times 2 times 4. Just type it straight in and see what it tells us. And it tells us that it is 17. Now we do need to check and make sure 17 doesn't reduce. It does not. So the correct answer for this is negative 7 plus or minus the square root of 17 over 4. Questions on this here? We're ready for the next one. 5x squared equals x plus 8. What do we need to do first? We need to get this equation equal to 0. What can we do first to get it equal to 0? we can subtract 5x squared. 5x squared minus 5x squared is 0. We'd have negative 5x squared plus x plus 8. Now, if we were factoring this or completing the square, we want that value of a for both of those for 1 to be positive. For completing the square, we need it to be 1. For the quadratic formula doesn't care if a is 1 or if a is positive. It just wants us to plug in the value of a, b, c, however they are. A is negative 5, b is 1, and c is 8. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. So our value of b is 1. So in the two places where b shows up, we're going to replace it with 1. A is negative 5. So the two places a is negative 5, or two places a are showing up in this formula, we're going to replace with negative 5. And then c, the one place it shows up, we're going to replace it with 8. Well, our negative 1 is just negative 1. The denominator negative 5 times 2 is negative 10. 1 squared minus 4 times negative 5 times 8. 1 squared minus 4 times negative 5 times 8 is 161. Now we do need to see if I can take the square root of 161, if we can simplify it nicely. So we can say second square root 161, tells us it's the square root of 161, so we get this here. Now we know there's not a common factor with the two terms on top in our negative 10, besides 1. Now for the most part, we don't want to leave a negative in the bottom of the fraction, if we can avoid it. So what we're going to do is we're going to factor that negative out, negative 1 out of the bottom, and we're going to multiply it through the top. Essentially, we're moving it from the bottom of the fraction to the top. Now, something interesting does happen, at least in part of it. Because the denominator is going to become positive 10. We get that because we remove the negative from it. Our negative 1 times the negative we're multiplying through is going to make it positive 1, yes? Didn't mean to put that. Yep. So its sign changed from negative to positive, yes? Now in the middle we have the plus or minus. So when I apply that negative to the plus is going to turn from a plus to a minus, because a negative times a positive is a negative. But we're also going to have to multiply that negative by the negative. And our negative times a negative is a positive. So really when we applied the negative to the plus or minus, the plus became minus, the minus became plus, which tells us it's still plus or minus. So really when we distribute that negative through, the only thing that's changing, or the sign that's changing, is the first term. The plus or minus still stays plus or minus. So 1 plus or minus the square root of 161 over 10 is the correct answer, or correct answers. Questions on this here? Are you ready for the next one? All right, this one here is a little bit different because we do have 4 terms. We have 2 on either side. That means we're going to have to move 2 things. So I can move everything over to the 25x squared, or I can move the 25x squared and negative 8x over. Either direction, we're going to have to move two things. So there's not one that's better than the other. So the first thing we can do is subtract 12x. Now 12x minus 12x cancels. 8x minus 12x is going to be negative 20x. Is equal to negative 4. Then we would add 4 to both sides, telling us 25x squared minus 20x plus 4 is equal to 0. All right. Now we need to find the values of a, b, c, yes? What's the value of a?
25.
B is?
20.
Almost. Negative 20, because we got to take the sign with it. And C is just 4, positive 4. Because if we have a minus or negative in front of it, we got to take the negative or the minus with it. Negative b plus or minus square root of b squared minus 4ac all over 2a. If you do not feel super comfortable with simplifying parts of this, the biggest thing I would say, especially on the test, is plug it all in like we're about to do. Because here, we can start with a, and we're going to plug a's value into its two spots. On bottom, right here. Then we can move on to b, two spots. And lastly, c goes up here. Because if you don't feel 100% comfortable with simplifying and reducing this down step by step, give me this to start with. Because that tells me I know how to set it up, I know how to do it. The only thing I'm going to lose points on or not get from here to the final answer if something goes wrong is less actually doing it and more simplifying. Now our negative 20, the negative and negative is going to make a positive. The denominator, 2 times 25 is 50. So at this point here, the only thing we have left to simplify is negative 20 squared minus 4 times 25 times 4. And again, at this point, I would just grab the calculator and type it in exactly as we have it written. Negative 20 squared minus 4 times negative 25 times, I think I've got those flipped. Yes. Yep. Negative 20 and then positive 25. Yep, got it. The negative 20 squared minus 4 times 25 times 4 is 0. Can we take the square root of 0? And if so, what is it? What times itself is 0? 0, yes? Questions on this so far? Can we add 20 and 0? Can we add 20 and 0 together? 20 plus 0 is 20. We can add these. Since we can add and subtract, we have to simplify them. Now 20 plus 0 is 20. 20 over 50, 20 divided by 50 will reduce to 2/5 or 0.4. We also have to do 20 minus 0 over 50. Well, 20 minus 0 is still 20. 20 over 50 reduces to 2/5 again, telling us that x is equal to 2/5, or x is equal to 2/5. We have two solutions, they're just the same solution. We only have one unique solution for this here. Questions on this here? Questions on anything we've done so far? Last quadratic equation we're going to look at, then we're going to look at one last thing, and we're done for the day. Done with chapter 3. So for this one here, we subtract 13 over, giving us negative x squared plus 14, or 4x minus 13 is equal to 0. Now the value of a is negative 1. B is 4. C is negative 13. So, plug in our values. So we can start with A. And the two places A shows up, one's in the denominator, and one's next to our 4AC. B, negative B and B squared. And lastly, C is our negative 13. Well, our negative 4 is just negative 4. The denominator 2 times negative 1 is negative 2. 4 squared minus 4 times negative 1 times negative 13. I mean, up to this point, it's not made a big difference. Let's see here. 4 squared minus 4 times negative 1 times negative 13. We've been able to just type the whole thing in and be just fine, yes? But here it gives us a domain error, which means that the value of b squared minus 4ac, that 4 squared minus 4 times negative 1 times negative 13, is actually a negative number. Which means I have to come back in here, tell it not to take the square root, tell me just what that is. Okay, so we have the square root of negative 36. Now, the 30xs cannot take the square root of negative 36. We have to do it kind of, it can do part of it, it can't do the whole thing. Now, the graphing calculator could take the square root of negative 36 as long as 36 is a perfect square. Here it is, so it would work. But otherwise, if it's not, the negative is going to come out as I. And all that's left for me to simplify with the radical is the square root of 36. So now I can come over here and ask it to take the square root of 36, which is 6, telling me that the square root of negative 36 is 6i. Now, just like before, we do need to simplify because there is a common factor of 2. Specifically, we're going to factor out or divide out this common factor of negative 2 from all 3 spots. Now, on the bottom of the fraction, negative 2 divided by negative 2 is positive 1. So we won't have to write the fraction again because the denominator is positive 1. Negative 4 divided by negative 2, the negative and negative make a positive. 4 divided by 2 is 2. The plus and minus. The plus becomes a minus and the minus becomes a plus, so it just stays plus and minus. So really, for the 6i, we're not so much concerned with the negative because all it did was flip the plus and minus. 6i divided by 2 is 3i. So really, when we divided plus or minus 6i, positive 6i by negative 2, it became negative 3i. When we divided the negative 6i by negative 2, it became positive 3i, still giving us that plus or minus. So it's there and it's not there all at the same time. Questions on this here? Now that's as far as it goes because 2 and 3i are not like terms. We can't add or subtract. Last thing we're talking about is the discriminant. The discriminant is the b squared minus 4ac. Now something interesting about the discriminant, it will tell us the number and type of solutions that we have. Because if the discriminant's positive, is a positive number, we will have a term for that square root, a number inside that square root, and it'll tell specifically that there's two real solutions. There's two values of x that will make the function be 0. Now they could be integer, rational, irrational, any of those types, but we will have two solutions. Now if b squared minus 4ac equals 0, we saw this once already today. That's where we had the 20 plus or minus 0. We had two solutions. We still had two solutions, but we only had one unique solution. So this here, we have one solution, one unique real solution. And if the b squared minus 4ac is less than 0, we have a negative number. It means we have to take the square root of that negative number, which gives us our I, telling us that we have two complex. It says two imaginary. I call it two complex terms. It kind of tells us what we have. Interestingly enough, if b squared minus 4ac is greater than 0, and the square root of that is a nice integer number, it simplifies completely. It tells us that the quadratic is factorable. It's a way to check factorability. So, we're going to look at these here. Now, when doing these here, finding the value of the discriminant and finding the number and type of solutions, we do need to make sure each of the equations before we start is equal to 0. It has to be equal to 0. All three of these are. So just like before, we're going to find the values of a, b, c. And for our equation here, the number in front of x squared, our a, is 1. Number in front of x, our b value is negative 6. And our c value is 10. Now, the first thing we want to do is find the value of the discriminant, our b squared minus 4ac. Well, b is negative 6, a is 1, c is 10. So we're going to say negative 6 squared minus 4 times 1 times 10. And it tells us it is negative 4. So the first, well, a third of the answer is that the discriminant's value is negative 4. Now, negative 4 is less than 0. And because the discriminant's value is less than 0, it tells me that I have two complex solutions. And this is all I'm looking for. You don't have to solve these here, because, and especially how I read the question, it says find the value of the discriminant. We did, it's negative 4. Number and type of solutions. Well, the number of solutions that we have is 2. The type is complex. We have 2 complex. Because if we wanted to, we could finish solving this using the quadratic formula. Because negative b said be negative negative 6 plus or minus the square root of b squared minus 4ac. Well, what's the value of b squared minus 4ac? We already found it. It is negative 4 over 2 times a, or 2 times 1. Our negative negative 6 is going to be positive 6. Square root of 4, negative 4 is going to be 2i. Divide both sides by, or divide everything by 2, simplify it by 2. Telling us that the solution is 3 plus or minus I. But that's it. Really, all I want is negative 4 and 2 complex solutions. I'm not throwing on, solving it on top of it. Questions on discriminant so far? If we look at the middle one, well, A is still 1, B is still negative 6, but C is 9. And if we plug this next one in, doing the same thing, we get that the value is 0, telling me that I have 1 real solution. Well, it helps if I type the right number in. 4. So it tells us that we have 2 real solutions. I think we feel comfortable with discriminants, because we could have ones like this here, but all it's saying is get the equation equal to 0, plug in ABC, find what we want. And that's it. Your homework assignment is 6 through 16 even, 21 through 24. So 6 through 16 even, you're finding the solutions of the quadratic equation using the quadratic formula. And then 21 through 24, you're finding the value of the discriminant and determining the number and type of solutions that you get. And that's it. That is also the